All right, IBAISL2. Today we're finishing off chapter 2 and talking about volume and surface area of 3D solids. So some shapes we're going to be dealing with today are the pyramid with there's lots of different kinds of pyramids depending on what type of base. You can have a rectangular pyramid or a hexagonal pyramid, so I'm just going to leave it loose and say any type of pyramid. The volume of a pyramid is 1/3 the area of the base times the height. Now, a pyramid is similar to a prism. It's like a prism that's been kind of chopped up. So I always remember that this right here is the area of the volume, of the prism. But then if you chop it into a pyramid, a pyramid version of a prism is always 1/3 the size of the prism that you're using. This 1/3 is going to come up a lot with pointy things like pyramids and cones. Like I just said, the area or the volume for a prism is just base area times height. So you can see that here, the base area times height. But if it's pointy, you're going to have to add that 1/3 in there. A cone is basically just a pyramid version of a cylinder. So a cylinder's area is pi r squared times height, which you already kind of knew because this is the base area. It's just the base happens to be a circle, and the area of a circle is pi r squared. Now, a cone is a pointy version of a cylinder. So here's the area of a cylinder right here, and then here's the pointy part, 1/3. Now, a sphere is, they told me to remind you in the book, is like 4 cones put together. Which is kind of true. But it's 1/3 pi r squared times height. But height is not a word. This is honestly the one that I forget the most sometimes, where I'm like, oh yeah, I gotta look it up. But I think most of these are probably on your formula packet. So I would check out your formula packet and see what you need to remember and what you don't. All right, let's take all these for a test drive today with multiple problems. First up, calculate the volume of each solid. Well, they're both pointy, so they're both going to involve that 1/3 area of the base times height. So here for this pyramid, volume is going to be 1/3 base area times the height. So this equals 1/3, and then the base area is a rectangle, so this would be 4 times 3.5. And then they give us the height of the total rectangle, so this is 7.4. Crunch that out, and you should get about 11.05. Remember, we're dealing with volume, so that's going to be units cubed, 11.05 centimeters cubed. Now, with this guy, I hesitate to even say it's a different formula because it's still just the way I think of it, it's still just the base, 1/3 the base area times height. It's just that the base area is a circle. So when you do the volume, you get 1/3 pi r squared times the height of, we don't know the height. So we have to do a little sidebar here. Because this is a right triangle, if you look at that slice, that's a right triangle. We can use Pythagorean theorem to say h squared plus 3.2 squared is equal to 11.5 squared. So 11.5 squared, take away 3.2 squared, and then square root that. You get 11.04. Sorry, 11.05, rounded to 2 decimal places. So 11.05 is the height, and then if you crunch that, you should get about 118 centimeters cubed. All right. The classic 3 tennis balls in a can. A cylindrical can holds 3 tennis balls. Each ball has a diameter of 6 centimeters. So I'm just going to go ahead and start drawing on here that from here over is 6 centimeters. And it's the same diameter of the top of the can. Yeah, so they're saying like that's also the same. So I guess they're saying there's no thickness to the plastic on the outside. That's nice that we don't have to think about that. Calculate the volume of the space in the cylinder not taken up by the tennis balls. Well, the volume of, I'm just going to call it the air around it, is going to be equal to can volume minus 3 times ball volume, because there's 3 of them. So let's think. The volume of the can is going to be pi r squared times height. Did they give us the height? Oh, they didn't give us the height. And you might think, oh my gosh, what do? I don't have the height. But remember, these are spheres. So that means that this from here to here is 6. Let's use a better color. Use black. That means this from here to here is 6. And then the whole ball is 12. So we have 12, another 12, another 12. So that's a height of 36. So the volume of the can is going to be base times height. But the base is pi r squared. The radius is 6. So pi 6 squared times the height of the can. So that's the can volume, but then we have to subtract out 3 ball volumes. Can we just say volume? Good one, Mr. Jolly. I bet everybody's cracking up right now. Wish I could see it. All right, we're going to find the 3 volumes. The spheres are, gosh, we just did it. It's 4/3, let's check. 4/3, I told you it's the one I forgot. 4/3 pi r cubed. So each of these are going to be 4/3 pi, and then the r is 6 cubed. We could go into the algebra a little bit. Like, for instance, these 3's cancel each other out. So then, like, 6 squared is 36. So this is like 36 squared pi minus 4 times 6 cubed pi. But are they even going to keep pi in their final answer? No, they're not. Like, if we wanted an exact answer, you would keep pi in the answer. But they're going a decimal approximation here. So we'll just crunch that out on a calculator and say this is 396 centimeters cubed. Now we're going to talk about surface areas. We've been doing volume this whole time. But surface areas are basically taking the shape and cutting it apart. So like flattening it. Sometimes the flattened version is called a net, where you like totally, make it 2D. So let's start with a cylinder. So if you have a cylinder, there's a circle on top and a circle on the bottom. So that's here and here when you cut it apart. But then around the side, there's going to be this rectangle that got wrapped around the circle. So if we're finding area, each of these are pi r squared. But then the area of the rectangle is going to be length times width. Now the length is like from the original height of the can over here. So that's going to be an h. But then the width is essentially the circumference of the circle. So if you snip the outside of a circle and unroll it along this top side here, that will be 2 pi r. So the area of this rectangle is 2 pi r times h. If we look at the cylinder formula, this makes sense because look, this is your 2 circles. This is your rectangle. Notice that with the rectangle, this is your length, 2 pi r, which came from the circumference of a circle, and then this is just the width, which is the height. The formula for a sphere is 4 pi r squared, so that's the outside of a sphere, the surface area of a sphere. The way I remember this is I always think about if you've ever seen a baseball, they kind of look like this. Something like, oh wait, I'm doing it wrong. Whoops. Come on, Jelly. Yeah, they have like a thing like this, and then another one over here. Something like that. Yeah, we'll have to look up a baseball. But essentially, they look like they have like 4 circles on. Like if you were to like take apart a baseball, you would get these 2 shapes that look like this. One like this, and then another one like this. So that, to me, kind of looks like 4 circles. 1, 2, 3, 4. So the surface area of a sphere, like each circle is pi r squared, but you have 4 of them. There is a way to cut apart the cone, but then you have to deal with like, the angle that's missing out of a circle and stuff like that. So we're just going to keep it simple and say that the cone is pi r L times pi r squared L. This L is referred to as the slant height. So that's this right here in the diagram. Slant height, L. It's like the side from the tip down to the base. Oh, and this part makes sense because this is the bottom. This is the circle that's on the bottom. And then this is the side cone, whatever you want to call it. Example 27. Find the total surface area of the rectangular base pyramid whose base has dimensions 10 and 8 and where the slant heights of the faces ABE and BCE are 12 and 13 respectively. That's nice that they gave us that. We're essentially going to cut this thing apart. When you cut it apart, the base is going to be a rectangle, and that rectangle is 10 by 8. So the area of this is 80 meters squared. Then there's 4 triangles on the outside, but they're not all the same triangles. Like this triangle right here is different than this triangle right here. Nope, different color, please. Yeah, this one, these 2 are different. But they do have matching buddies on either side. Like there's another green one over here, and then, let's see if this will work. There's an orange one back here that does match up. So we're going to do this plus 2 of this triangle. And this triangle is, we can just do 1/2 base times height because the slant height hits at a 90 degrees. So 2 of 1/2, no, I was drawing pictures. There's 2 of these that have 12 and 10. And then we're going to add 2 more triangles that have a base, the side ones have a base of 8 and a slant height of 13. So, surface area, is that the notation they're using? No. I'm going to use SA for surface area, is going to be the rectangle, which is 80, but then 2 times 1/2 base times height. And then there's 2 more that are going to be 1/2 base times height. When you add those all together, I believe you get 304 meters squared. That's that problem. Last example, a cone has a radius of 5 and a total surface area of 300. Oh, this time they're giving us the area. That's interesting because we're going to have to do some backwards solving. Find the slant height of the cone and then the height of the cone. Well, first of all, I don't like doing any of this without a picture. So we're going to do our best to draw a cone. And what do they give us? Oh, the radius is 5, so we can put a 5 right here. Okay, if we go back up here to our formula for a cone, the formula for a cone is pi RL plus pi r squared. So since they gave us the surface area. Yeah, that is the surface area, not the volume. So the surface area is going to be pi RL plus pi r squared. We know the surface area is 300 because they give it to us in the problem. We know that the pi is pi and the radius is 5. We don't know L, and then we know the radius is 5 squared, or that part is 5 squared. So let's figure out what we can do here. Well, I guess really first I can only clean up a little bit and say this is 5 pi L plus 25 pi. Now 25 pi is just a number, so we can actually subtract that from the other side. We get 300 minus 25 pi is equal to 5 pi L. Then divide both sides by 5 pi, and we get 300 minus 25 pi over 5 pi is equal to L. When you do that and solve, because like this whole left side, the left side, not the right side, is that's just calculator work. So punch in 300 minus 25 pi divided by 5 pi. Make sure you put parentheses around your 5 pi in the denominator. The decimal equivalent is, this is 14.1 centimeters. Right? We're in centimeters? Yeah. So that means that L, just get rid of it, is 14.1. So that was part A, finding the slant height. Now for part B, it says find the height of the cone. But remember, the height of the cone meets the base at a 90-degree angle. So we actually have a right triangle here where we know the hypotenuse and one of the sides. So we can use Pythagorean theorem. H squared plus 5 squared is going to be equal to 14.1 squared. Then when you solve that, you get H is about 13.2 centimeters. All right, you guys, that's all I have for us today. Come ask me questions in class if you're struggling with homework problems.